Hi, everybody, and welcome to this month's Code Presents webinar. We're glad you could join us today. This month, we're going to focus on options for moving your .NET application to the cloud. The agenda includes reviewing the findings from a GigaOM benchmark study, which compares migrating an on-prem ASP.NET application to Azure versus AWS, revealing some of the benefits and trade-offs between the platforms and more. We're going to be joined today by Microsoft Azure App Service Program Manager, Gaurav Seth, and GigaOM analyst, Ned Bellavance. You'll learn more about them shortly. My name is Jim Duffy, and I'm the Director of Business Development for all the Code divisions and services. Code is so much more than just a magazine. Code Magazine is our flagship, of course, but our other divisions include Code Consulting, where we do custom software development projects, Code Training and Mentoring, and Code Staffing. If you're interested in reaching out about any of our code services, my email address is on this slide. If this is your first time attending one of our webinars, welcome and thank you so much for joining us. If you've attended one of our webinars in the past, welcome back. We have experts in the chat window to answer your questions. If you don't currently subscribe to Code Magazine, we can take care of that. As a benefit for attending today, all registered attendees will automatically receive a free Code Magazine subscription, provided you don't already subscribe. I've also included a free subscription link for you to freely share with others who couldn't make it to the webinar today. Our continuing mission is to help people build better software. We're a Microsoft partner, and we build and maintain custom software solutions. We also modernize legacy applications and migrate existing applications to the cloud. Whether it's a cloud-based or an on-prem solution, a web application, a mobile app, or a Windows desktop application, we can help with whatever platform you're targeting. Our team of expert developers and consultants are ready to help you with your project. Our very popular and in-demand free hour of code provides an opportunity for you and or your team to meet with our hand-picked expert team to discuss anything you could use our help with. Ask us about software development technologies or platforms, languages or databases, front-end, middle tier, or back-end tools or platforms, best practices, architectural design, or whatever you need help with. Schedule your call today and let us help. No charge, no strings, no commitment, just free help from our code experts. Slots are limited, so reach out to me about getting a free hour of code scheduled for you and your team. If you like what you've seen today or have seen in our prior webinars, please subscribe to our YouTube channel, follow us on Twitter, and like us on Facebook. We would like your feedback about this webinar in the form of a quick survey, and we're willing to pay $100 to one lucky winner. Their survey is very short, and you'll finish it in no time flat. The survey link is on the slide, and we'll put it in the chat window as well. It's almost time to turn things over to Gaurav and Ned, but before I do, I want to share with you that the slides and recording of today's webinar, and all of our webinars, are available on the Code Presents webpage on the Code website. I've included that link on the slide. Okay, you've heard enough from me. Thanks for listening. Take it away, Gaurav and Ned.
Hello, everyone, and welcome to the Azure webinar series. First of all, thank you for joining in. Now, over the next hour, we will be talking about how can you save time and cost by migrating your .NET web applications to Azure. Now, let me start by a quick introduction of the speakers. So my name is Gaurav Seth. I am a program manager on Azure App Services team.
And I am Ned Bellavance. I'm an analyst at GigaOM. Thank you so much, Gaurav, for starting us off. And let's dive right in by talking a little bit about the agenda for today. What are we going to cover? We are going to start out with the GigaOM benchmark that this webinar is loosely based off of. It's a benchmark study that I conducted as an analyst for GigaOM. We'll get into what are some of the benefits and trade-offs when it comes to moving your application to a different platform. A few considerations, especially for ASP.NET migrations. That's the specific app that we're going to focus on today, is an ASP.NET app for at least the benchmark portion of the presentation. We'll talk about various Azure services that are available out there for .NET applications, and then some advice, a little bit of how to get started if you are interested in trying to move one of your existing applications. How would you go about doing that? So before we jump into the benchmark itself, I wanted to talk a little bit about the various migration options that are out there when you're thinking about taking your application and moving it from on-premises, your own data center, to some sort of cloud provider. And there's like 6 R's around the different migration options. And I'm not going to do all 6 R's. There might even be 7 now. It's hard to say. But the first one, and if we're talking about the least level of complexity in terms of migration, the relatively easiest one is to rehost your application. That's also called lift and shift. And the idea here is your existing application runs on some virtual and potentially physical servers in your data center. You want to move that application to the cloud, and rather than changing the application in any way, you're going to either virtualize if it's on physical servers, or take existing virtual machines and move them to whatever format the cloud provider you are targeting is using. So if you're moving it to Azure, you would go through some sort of conversion mechanism to turn that virtual machine into an Azure virtual machine. And that's it. That is the extent of your work in the migration. It's a relatively simple migration, but it also doesn't bring you a whole lot of benefits of the cloud. Sure, you're not responsible for the hardware anymore, but that's about it. So a slightly more complex migration, but one that might reap some additional benefits, is called a re-platform, or move and improve. The idea here is to take advantage of some of the platform as a service options that you have in the public cloud providers. Platform as a service abstracts away some of the infrastructure underneath and allows you to just consume a platform like web services or database services just as that service, as opposed to worrying about the underlying virtual machines and hardware. So by re-platforming your application, you're probably not changing it in any significant way. For instance, if your application has a database backend today that's using Microsoft SQL, no problem. You can take advantage of, say, Azure SQL Database, which is database as a service, and move your database to that instead. Now you no longer have to worry about managing that underlying server that serves up SQL Server or some of the internal SQL Server bits. You're really just saying, hey, I need a database, and it gives you a database. So that's nice. It's a little more complex than a rehost, but it's not as complex as the next level, which is refactoring. And now we're actually getting into modifying some code for the application to better fit the shape of the cloud. And oftentimes that is going to involve maybe moving from one type of service to another. And an easy example of that is if we run with our database example, you have a relational database on the back end of your application. And it occurs to you that you don't really need a relational database. You could use one of these new NoSQL databases. So why not take advantage of that, rewrite a little bit of your code, and now use something like Cosmos DB or Document DB on the back end for a non-relational database. And maybe it's a little bit faster, maybe it's a little cheaper. There's a bunch of reasons you might do that. So that's actually modifying code in your application to take advantage of a different cloud service that you might not have in your data center today. Obviously, that's some more work. It's going to require some more testing, but there's some definite benefits around that. And then finally, there's the big one, the rewrite. This is when you actually rewrite your application for a cloud native infrastructure. And the idea here is maybe your application is a monolith today or mostly monolith. And instead, you're going to rewrite it as some microservices. You're going to break it out into containers. Maybe it's going to run on Kubernetes, like all the things that you might not have in your data center today. That is a very heavy lift. And it's not very often that organizations will undertake that full rewrite of their application right out of the gate. What tends to happen, or at least the ones that see the most benefit, is by starting with either a re-platform or a refactor. It's the right level of complexity for migration. It's not terribly cumbersome, but it also gets you some quick wins. Now you're able to take advantage of platform as a service as opposed to just doing a straight lift and shift of your application. So with those migration options in mind, let's get into the scenario that GigaOM was trying to test in regards to migrating an application. The application type that we were looking at migrating from an on-prem environment was an ASP.NET web application. I know there are a ton of those still out there, still running on-prem, still doing very important work. So we wanted to look at what would be involved in moving that application. Now, one of the conditions of that is any application we move has to maintain or improve the overall performance of that application. Otherwise, there's not a ton of benefit to moving it to the cloud. You expect it to function better in the cloud, not worse, right? We also wanted to see if we could simplify the level of administration required for that application. Can we make it easier for the ops side to be able to maintain that application and maybe get rid of some of the underlying layers from their management, make that somebody else's problem? And then finally, is it possible to have a lower total cost of ownership by doing that migration as well? That's the scenario that we were looking to investigate. Now let's take a look at the benchmark environments that we used to investigate this scenario. I designed the benchmark to have 3 different environments, one for on-premises, one for Microsoft Azure, and one for Amazon Web Services. In the on-premises benchmark environment, that was composed of VMware virtual machines using Nginx as a load balancer. This is something very similar to what you'd have in your data center today. Chances are you're probably running VMware and your application is probably running on virtual machines, and it's probably using some sort of Microsoft SQL Server backend. And so those were the components that went into the on-premises environment. If you want additional details about exactly what's in this environment, I would refer you to the benchmark study, which is available for free. So I'm not going to get into the deep details, but just an overall, that was what was running on premises. For Microsoft Azure, we selected the Azure App Service to host the web front end of the application. And the size of the service, or the SKU, was the Premium 1 P1 V3 SKU. And like I said, that was just for the web front end of the application. The database backend, instead of spinning up a virtual machine running SQL Server, we instead decided to take advantage of Azure SQL Database using the Gen 5 version of it with 4 virtual cores for that backend, which was similar in size and nature to the virtual machine running SQL Server in our on-premises environment. And then finally, for comparison's sake, we want to see how we could run this on AWS. The closest comparison service is Elastic Beanstalk, so we chose to use that, and the EC2 instances, which is basically the same as virtual machines, but they call them EC2 instances. We went with the M5D.large size, which is comparable to the virtual machines that are behind the App Service Premium P1v3 SKU. So those were very comparable. And then for the database portion, we went with RDS and a DB M5 extra large size, which is comparable to that SQL Gen 5 with 4 vCores. So in terms of hardware and the virtual machines backing the application, it was very close, if not completely the same for each environment. There are subtle variations because hardware has subtle variations, but in terms of generations of processors and amount of horsepower, all 3 environments were almost exactly the same. The application that we tested for this is the Parts Unlimited application, and if you wanted to take this for a run yourself, you can find it on GitHub at the link that's on the slide. Now let's talk a little bit about the migration process. For the migration process, I first started by deploying the application from Visual Studio using the IIS publish option to publish the application to the web servers. So that was a very simple and straightforward deployment process. Could have gone with a more complicated CI/CD thing, but that wasn't really what we were trying to prove. So simply deployed it through Visual Studio and then ran some transactions, make sure that it was working, and then backed up that SQL database that was part of that initial deployment. And then I set up the infrastructure on Microsoft Azure that we were going to target for the application deployment. So set up that app service environment and the SQL database, Azure SQL database, and then deployed the application using the Visual Studio Azure Publish option. So all this happened within Visual Studio, very simple and straightforward to get the front-end code running and then did a restoration of the database to Azure SQL database. And that was actually relatively simple as well. It was remarkably smooth. I was a little concerned at first, but it all worked. And then for AWS, once again, I had to set up the Elastic Beanstalk and RDS environment ahead of time. And then I deployed the application to AWS using the AWS Toolkit extension for Visual Studio, and then restored the database. So the process for each was very similar, taking the same code base and deploying it to 3 different environments, and then restoring the database from the on-prem environment to the other 2 cloud environments. In terms of migration, I have to say that the tight integration with Azure and Visual Studio made publishing that probably the easiest of all of them, but the AWS Toolkit also worked fairly well. I ran into a few bugs with that, but your mileage may vary depending on what version you end up using. In terms of changes to the actual code, it almost didn't require any changes at all, except for things like connection strings. Otherwise, the actual application itself stayed consistent across all 3 environments. Now, to test the performance and benchmark the results of the 3 different environments, we used a load generator that basically ran 3 different tests against each environment. Each test lasted an hour and ramped up to, I believe, 50 concurrent workers, all sending as many sessions as they possibly could against each environment. And so the 3 tests that we went through, the first one was a basic homepage load. And this is an actual, it spins up a virtual browser and then tries to load the homepage in the virtual browser, and it times to see how long it takes for the homepage to complete loading. And then the next test that we did was an item search. And again, this is loading up a browser, plugging a search term, the same search term, into the browser and seeing how long it took to have search results publish in the browser. And then the last one was going through a full item purchase transaction where an item was selected, added to a cart, and then purchased through the application. So this application is basically, it's a web store for automotive parts is the example application. So we went through the whole load the homepage, search for an item, and then purchase that item, and recorded how long each session took, and then the total number of sessions we were able to complete over the given testing period. As you can see, the average session time was pretty consistent for the homepage across all 3 environments. AWS had a slight edge, but it was really within, I think, 100th of a second. It's hard to tell from the bar graph, but it really was very close. For whatever reason, item search was much faster on the clouds than it was on the on-premises environment, and same with item purchase. The cloud environments just seemed to outperform, even though the hardware was very close in nature. When it comes to total sessions, Azure ended up being the highest number of completed sessions out of all 3 environments, especially with item purchase, where it really just flew ahead of the other ones. So obviously, the thing that we wanted to show was that the performance of the application once it moved from on-premises was going to be as good or better than the existing environment. And in both cases of Azure and AWS, it was at least as good, if not much faster in some cases. So that makes me feel good about moving the application. Another thing that we wanted to consider was cost. And so we looked at the total cost of ownership of the on-premises environment, the Azure environment, and the AWS environment over a 3-year period. And we absolutely considered some of the special benefits that the cloud has when it comes to pricing, especially when it comes to reserved pricing. When you reserve an instance or a SQL server, the Azure SQL database for 3 years, you get a discount on the cost of that because you're saying, hey, I'm committing to this thing for 3 years. So there's definitely a cost savings there. That was factored in wherever we could do a reserved instance. We did on both Azure and AWS. So what did we find initially when we compared the cost of running in Azure to the cost of running in an on-premises environment? What we found is the TCO was actually 39% less expensive to run in Azure over an on-premises environment. Some of the things that we factored into that is the on-premises environment includes about one virtualization host for all those virtual machines, the licensing to run VMware, and then power and cooling. We didn't factor the operational human cost, the cost of having people managing it, because they're still going to have to manage the application when it moves. So as far as we're concerned, that's a wash. Now, one thing that Azure offers is the Azure Hybrid Benefit License. What that means is if you have existing SQL Server licenses in your on-premises environment, and they have that hybrid benefit associated with them, you can move that license and use it in Azure and save on the licensing costs you would otherwise have to pay for things that are running in Azure from a Windows licensing or a SQL licensing perspective. Now, we know SQL licensing isn't cheap. And if you do apply the Azure Hybrid benefit, the savings over on-premises jumps up to 54% because now you don't have to repurchase that licensing. So that was a huge saving over on-premises. When we compared it to AWS, AWS doesn't support the Azure Hybrid benefit. That's only available on Microsoft Azure. If you use the same services in AWS, the licensing cost of Windows and SQL is bundled into the cost you pay for the service. Due to that and just the general cost of running virtual machines, we found that AWS was 30% more expensive than Microsoft Azure for what was essentially the same deployment. So if we break it down by sessions, say for every 10,000 sessions, what's the cost of running the environment? The on-premises environment came out to about $1.75 per 10,000 sessions. AWS came out to $1.12, and Azure came out to 79 cents. Now, one thing that I didn't mention, but is important to remember about cloud is it is consumption-based, which means that you can dynamically scale the web front end or the database back end to meet the current demand on the application. So in situations where you know you're going to have lulls in demand for the application, you can spin down some of the instances that you have running in your app service or Elastic Beanstalk and save on the cost of having those instances there, and then request those instances later when you know that demand is going to rise, or you can monitor different performance counters to see if it goes over a certain threshold, add additional instances, and then scale back down once the demand also drops. So that dynamic ability to scale out and scale in of your environment is pretty hard to implement on premises. And I think it's a huge benefit when it comes to the cloud from a cost and performance standpoint. Now, one other thing that we wanted to look at was simplifying the administration of the environment. And when it comes to doing the migration, there's actually several trade-offs that happen in terms of whether or not to migrate and what the challenges might be. And so I wanted to look at this in three different dimensions. And this is more of a qualitative view of things. In terms of simplicity, if you think about how easy it is to manage the application and its underlying infrastructure, the on-premises environment is the least simple. It's the most difficult to manage because you're responsible for the hardware, or at least your ops team is responsible for the hardware, for the software, and you're also managing the application itself and the performance of the application. So there's a lot there. If we move to a more simpler environment, the AWS environment does add some simplicity. For those who have not used Elastic Beanstalk, it's not a fully managed service per se. It's a somewhat managed service, almost an abstraction on top of other cloud primitives in AWS, like auto scale groups and load balancers and a database server. So because of that, it's not fully managed, but it does add some simplicity in terms of management. So I kind of put it somewhere in the middle. And then the Azure solutions that we selected, App Service and Azure SQL Database, are almost fully managed solutions. You do have some level of things that you can change and tweak, but you're not responsible for patching the virtual machines, patching the firmware and the underlying hardware, or any of those kinds of things. So Azure, I think, was the simplest of the three ongoing for management. Now, in terms of flexibility, simplicity is kind of a trade-off with flexibility. Because the Azure services are fully managed, you have somewhat less flexibility because you don't have access to some of the underlying components. You don't have full access to the virtual machines in the app service. You don't have full access to the database servers that are running Azure SQL database. Only certain features are exposed to you. So if you require getting into those deeper features, then the solutions that we selected might not make sense for you. AWS exposes more of those features because of the way that Elastic Beanstalk works. It really is just a veil or an abstraction of other components that are running in AWS. So you have full access to those components and you can configure them as you want. It might break the integration with Elastic Beanstalk, but if you needed to, the flexibility is there. And then lastly, on-prem is going to give you the highest degree of flexibility because it's your environment. You can do whatever you want. Of course, that means that you're also responsible for managing that additional complexity you've added, but it is the most flexible of the environments. From a fully managed perspective, I kind of mentioned this already, but you're responsible for every component in your data center, or at least your organization and your ops team are. So on-prem is going to be the least managed. The AWS Elastic Beanstalk is going to sit somewhere in the middle, and then the Azure solution is almost fully managed. So there are some trade-offs when you're selecting different services in the cloud, and you have to take into consideration what level of simplicity you want versus flexibility, and understand that the more flexible a solution is, the less simple it is, and probably the less managed it is. So if I could just summarize what I discovered over the course of the benchmark and tie it all back to the scenario, we wanted to see if an application that we migrated was as performant or better. And it turns out it was more performant in the clouds. We wanted to check on simplifying the administration of the application. And I can say that administering these applications ongoing is going to be much simpler, especially on the Microsoft Azure services. And we also want to look at the total cost of ownership. And I think it's pretty clear that moving to Azure for the application was going to be the least expensive, have the lowest total cost of ownership of the three. So I think that migrating ASP.NET applications, assuming that the cloud target meets all of your requirements, probably makes a lot of sense. Now, to dive a little bit more into the Azure components of things, I want to bring back in my co-presenter, Gaurav. Why don't you take over and tell us a little bit more about running .NET apps in Microsoft Azure?
Thank you, Ned. In today's uncertain business environment, operating cost effectively is top of mind for IT and business leaders. Azure offers the only end-to-end application hosting platform to build and manage .NET applications, enabling significant cost savings, operational efficiencies, and business agility. Leveraging Microsoft's deep expertise in Windows, Visual Studio, and ASP.NET, we have designed App Service and Azure SQL DB from the grounds up for .NET application and the SQL Server database that powers them. And with a free migration assistance, it has never been easier to get started. Now, let me share a few more ways on how migrating to Azure can help accelerate your .NET app modernization. Now, as Ned just shared, Azure is the most cost-effective cloud if you just look at the performance for .NET apps. Here are some additional ways how Azure can help you optimize your cost. First, operating your .NET applications on a fully managed platform allows your teams to focus on what matters most by offloading management of your apps and data to Azure. For example, you no longer need to worry about operating systems, database, or .NET runtime patching. You can leverage the automatic backup and built-in high availability options to improve business continuity. Now, secondly, you can also leverage the power of built-in intelligence capabilities that surface opportunities for you to save. Azure SQL Database offers built-in AI-powered automatic tuning and adaptive query optimization to support peak performance. You can also analyze if increased traffic or upstream dependencies are affecting your website response times with our out-of-box monitoring for ASP.NET apps in Azure Application Insights. Thirdly, get more cloud for less. What that means is with Azure hybrid benefit and reservation pricing, savings can amount up to 80% off compared to pay-as-you-go rates. So what other benefits can you expect? Here are some more ways how you can realize cost savings with .NET apps and Azure App Services and SQL Database. With Azure's Enterprise Dev Test offer, customers and partners can qualify for discounted rates to support your ongoing development and testing on Azure. And you can save up to 49% compared to pay-as-you-go rates for services such as Azure App Services, SQL databases, Windows virtual machines, and more. Additionally, according to a recent Forrester Total Economic Impact study, developers and database admins see up to a 50% increase in efficiency and team velocity. With Azure's managed services, and companies using Azure managed services can realize up to a 414% 3-year return on investment with a payback period that's less than 6 months. Now we talked about cost savings. Now let me share some ways how migrating .NET apps to app services and SQL database can help simplify operations while enabling you to operate confidently to address any business needs. Now, with built-in auto scaling, you can easily scale up to meet peak demands and scale down when demand goes down, ensuring that your user experience stays great. With Azure App Service, we have a proven enterprise-grade platform that serves millions of sites, processing billions of requests and trillions of SQL queries every day. Now, both App Service and SQL Database is available in all 60+ Azure regions, enabling you to deploy your applications to be closer to customers and meet local regulatory compliance needs. Now, with the Windows version of App Service operating on an IS server in the backend and Azure SQL Database sharing the same code base with on-premises SQL Server, your developers and database admins can leverage the familiar tools and processes to be effective from day one without a steep learning curve. For example, SQL database admins can leverage SQL Server Management Studio and familiar features such as dynamic management views to analyze and optimize database performance. And in terms of security, Azure offers the best enterprise-grade security in the cloud. Now, interestingly, Microsoft invests billions in security annually and employs a team of more than 3,500 plus global cybersecurity experts that work together to help safeguard your business assets and data in Azure. With Azure Security Center, you can monitor all your Azure resources such as virtual machines, applications, and databases, and review recommendations to improve your security posture. Azure SQL Database offers built-in security controls across T-SQL, user authentication, networking configuration, and encryption key management. You can also protect your web applications with Azure Web Application Firewall, leverage Azure CDN to optimize performance, or use Azure Front Door to route user traffic to the lowest latency backend while gaining built-in DDoS protection and global load balancing. We talked about how you can optimize cost and operate confidently with .NET apps on Azure. While this is essential, you might be wondering how your developers can build and ship new features faster with the cloud to meet the changing market conditions and to address your customer needs. Now, developers can build and ship changes faster with native integration between Visual Studio, GitHub, and App Services and CI/CD integrations. For example, you can continue to use Visual Studio to perform remote debugging for dev test environments and live site snapshot debugging for production environments. Now, enabling both developers and operators to use familiar tools to diagnose and solve issues quickly. Next, developers can easily connect to new data sources and backend systems using 300 plus pre-built connectors for Azure Logic Apps. You can also turn legacy web services into modern REST-based APIs by creating facades using Azure API management. You can also leverage many of the pre-built Azure APIs for cognitive services such as speech, text, and image processing. You can add interactivity on your website with Azure Bot Service to serve customers efficiently and deliver personalized results with Azure Cognitive Search. Finally, with services such as Azure Active Directory and built-in security controls, your development team will be able to innovate without compromising security. For example, you can easily add multi-factor authentication with Azure Active Directory and use Azure AD B2B and B2C features to enable customer, partners, and employees to securely access your apps. Now let's shift gears a bit and talk about how you migrate your .NET apps to Azure. Now, Azure Migrate provides a hub of tools to discover, assess, and migrate on-premises applications, infrastructure, and data. Now, there are two particularly useful tools within Azure Migrate that we'd like to bring to your attention. Firstly, the App Services Migration Assistant is designed to simplify your journey to the cloud through a simple and fast solution to migrate .NET applications. Now, over the last year, we have seen customers and partners run tens of thousands of assessments and migrate their .NET apps using this tool. With this tool, you can quickly assess whether your app is a good candidate for migration by running a scan of its public URL, and then use the tool to run readiness checks and general assessment of your app's configuration settings, then migrate your app or site to Azure App Service in just a few clicks. The second tool is the Database Migration Assistant, which helps you detect any compatibility issues that can impact database functionality in Azure SQL database. You can easily assess on-premise SQL Server instances, identify migration blockers, and unsupported or partially supported features. Now, DMA also allows you to move your schema, data, and uncontained objects from your source server to your target server. Now, these tools are free of cost, and we have a Microsoft Learn module for you to test these in a sandbox at the URL you will find in the resources section. Now, let's see a few customers who have undertaken this .NET apps migration journey. Now, one of the first customers worth mentioning is Clover Imaging Group. The Clover Imaging Group is the largest collector and remanufacturer of printer cartridges in the world. When Clover was looking to modernize their .NET apps and improve security for DDoS protection, they turned to Azure. Since then, they have the Azure Migrate tool to seamlessly migrate 200 applications over. As an application development team, they really like the value proposition of App Services and SQL database as fully managed service without having to worry about security patching with virtual machines or containers. The second customer I want to talk about is Viking River Cruises. When Viking was looking to modernize their .NET apps portfolio, they reached out to one of our partners, Mobiz. Now, Mobiz has heard about the Azure Migrate tools for migrating .NET apps to app services. They found that they were able to migrate more than a dozen line of business applications for Viking, such as an HR application using the migration tools in a matter of minutes. Lastly, Chipotle, which operates more than 2,500 restaurants across North America and Europe, took a different path to modernization by moving to .NET Core and leveraging Azure Managed Services. Now, in addition to the Azure Migrate tools for web apps and database migration, this year we have also launched the Azure Migration Program offer for .NET apps. Now, the Azure Migration Program offers proactive guidance and the right mix of expert help at every stage of your migration journey. Here are some things that the AMP program offers for your migration journey. Best practices for a step-by-step approach from start to finish. Technical skill building to ensure your organization is set up for success to adopt Azure. Fast track for Azure engineering assistance. Expert guidance from specialized migration partners. Free Azure tools like Azure Migrate to help you efficiently execute migrations. And finally, some cost-effective offers to help you save money before, during, and after migration. Now, you can submit a nomination for your migration at azure.com/AMP. Now, here is a link to resources that should help you get started on your migration journey, and please feel free to go over them with your own convenience. Now, in summary, Azure is the only cloud that offers a fully managed platform for your .NET apps with app services and SQL database, delivering cost savings, operational efficiencies, and agility to ship faster, while offering the lowest total cost of ownership, as GigaOM found out in their performance benchmarking. Now, this is what I wanted to talk about as part of our webinar today. It's time we open up to some questions and answers. So please do post your questions, and we'll try and answer as many as we can in the allocated time. And once again, thank you for joining us today. I hope this session will be super helpful for your migration journey to Azure. Thank you.
No, thank you, Gaurav and Ned, for that awesome presentation and the valuable information you shared. Before we wrap up the presentation and focusing on answering questions, there are a few announcements and reminders. I've pulled out the link to the benchmark study PDF from the resources slide to make it quick and easy for you to head over and download it. I'll remind you that we're very interested in your feedback about the webinar and would appreciate you taking a moment or two to complete our survey. It's all of 12 questions, and you'll fly right through it, and one lucky survey submitter will be drawn and receive a $100 Amazon e-card. Another reminder that through our free hour of code offer, you can ask for our help on whatever you or your team needs. No strings, no commitments, no credit card required, just help from our code experts. Reach out to me about scheduling your free hour of code. The Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. Mark your calendar for Wednesday, April 28th at 1 p.m. Eastern for our next State of .NET webinar, where Marcus Egger will dive into the current state of Azure and keep you up to date on the latest developments in Azure. That's it for today's presentation. Don't forget to like us on Facebook and follow us on Twitter. If you're attending live, we'll be in the chat for a while answering as many questions as we can. If you're watching the recording, please don't hesitate to reach out to me or through any of our communication channels. Thanks for attending, everyone. Have a great rest of the day or night, wherever you are.